some standard derivative. So we have if y equals to f of x. So here we want to find dy dx, which is simple as what f1 of x, right? Okay. So let's look at the first one. If y is a constant, so we use c or k. Okay. So if y equals to a constant, what is the derivative? A constant, any constant. If you differentiate a constant, it gives you zero. It gives you zero. Okay. So if you have x raised to the power of n, x to the power of n now. So the derivative will be n x raised to the power n minus 1. So what this means is that whenever we are doing our derivative, we are differentiating now, and you now go to where you have to differentiate a constant. Okay, just know that the derivative is what? Zero. So whenever we see x raised to the power n, this n can be any power, whether negative or positive. Then you're going to have n x raised to the power n minus 1. So what about if you have k x raised to the power n? Kn x raised to the power n. So this will give you kn x to the power n minus 1. Okay. Exponential x. If you differentiate exponential x, that will still be exponential x. 5. If you now differentiate exponential kx, that will be k exponential kx. Okay. So 6. You have to differentiate a raised to the power x, where a is any constant. So what is the derivative of this? To be So now you observe that the x is now serving as a power. Okay. So the result of this is ax ln a. So this one is natural log ln ax ln a. So how do they arrive at this? It's very simple. So this is the function we want to differentiate. We have y is equals to a raised to the power x. Okay. Now, because it is power now, what we now do is we apply logarithm to both sides. We take the natural log of both sides. Okay. Applying natural log of both sides, because one of the laws of logarithm is to give you x ln a. Right? Now, ln a that we have here is just a constant. So, but here, the ln that we have, a ln y, we now differentiate. Okay? So, anytime you differentiate ln, what will it give you? 1 over. Good. This will give you 1 over y. But because you are differentiating y, if after differentiation, you have to add what? You have to add dy dx. Okay? So this will be equal to, now differentiating this will only give you ln a. If you differentiate x, that will give you 1. And don't forget that ln a is just a constant. So 1 times that ln a, that will be ln a. Now, if you multiply both sides by y, we have dy dx is equals to y ln a. But what is the y? Y is a raised to the power x. So that is why we have a raised to the power x ln a. So what is the derivative of ln x? What's the derivative of ln x? Hmm? 1 over x. So the derivative of ln x is 1 over x. Okay. 8. We are looking at standard derivative. So all this we need to know. They have to be here. Okay? You don't need to cram. But by the time you are using them, while you are solving exercises, then it become part of you. You don't need to cram anything. So let's move on to the trigonometric functions. What about sine x? What is the that is what? If you differentiate sine x, that will give you cos x. Okay, cos x. Cos x. So these are additional standard derivative. So the derivative of cos x is minus sine x. That of sine x is sec squared x. Cos x is minus cosec squared x. Cosec can be shortened as CSC. Okay. So anytime you see CSC, you know that it represents cosec. Okay. Sec x is equals to sec x tan x, and cosec x is minus cosec x cos x. This is sine x. This is hyperbolic function. So for hyperbolic function, this is pronounced as sine x, and derivative of sine x is cos x. For cos x, this one is sine x. Observe that this one does not have minus. So for sine x is cos x, and for cos x is sine x. Okay, so you can later you will be asked to get this one. So take this and keep it for yourself. You'll be the one that will find the derivative of. We pronounce this as dan x. Yes, like dan x. So this is what sine x. This one is cos x, and this one is dan x. So you'll be the one that will provide this solution later. Okay, so let's look at a few examples. So let's quickly recall from the standard derivative. So what will be the derivative of y equals to exponential x over 2? So remember that this can be written as exponential 1 over 2x. Okay, all together. So the fact that 1 over 2x means 1 over 2 times x, but x is the same thing as x over 1. Okay, so that numerator multiplies numerator, we have x, denominator multiplies denominator, and we have 2. So that's why we have it as x over 2. So we can separate to have 1 over 2x. Now look for one of the standard derivative that exponential 1 over 2x look like. Among the standard derivative that we have written, which one does exponential 1 over 2x look like? So what do we have there? E raised power. No, check very. Among the standard derivative, which one does this one look like? Exponential. Now look at what you have there. No, this one does not look like e raised power x. This is e raised power kx, because you have a number before the x. That's it now. So exponential kx. That's what it looks like. So what will now be the result? It's said to be k e kx. Have you? Okay. So if this is the same thing as k exponential kx, and the result is k exponential kx, so what will be the result here now? What's our k now? 1 over 2. So that's 1 over 2 exponential 1 over 2x. So that's it. That's the derivative. Alright. So move on to the next one. That one is just exponential x. And we know that derivative is just exponential x. So what about sine x? Sine x is just cos x. Cos x. What about a raised power 3? A raised power 3. So don't forget that a is a constant, I mean. So a raised power 3, yes, the derivative. Okay. It says 3 a raised power 2, right? Okay. What any other idea? A raised power 3 ln a. Okay. A raised power 3 ln a. Any other idea? So you're all wrong. So this is supposed to be 0. So if I observe that you don't see any function of x there, you don't see x here, and I ask you to differentiate with respect to x, it means that everything you have here is a constant. A raised power 3 is still a constant since you do not see x there. So and if you differentiate the constant, that gives what? 0. So that's 0. Alright, now what's the derivative of ln k? Ln k. 1 over. So also again be careful. I intentionally put this here. K is not x. It is ln x, that if you find the derivative dy dx, that you have 1 over x. This is ln k. It means that this thing that you have here is a constant. Okay, and when you differentiate, you have what? 0. Okay, so here now you can see, and I put y and 2 raised to power x. This one is clear. You must know the result of this one. So what will this give us? Dy dx will be 2 raised to power x ln. So what's the a in this case? 2. So ln 2. Then so. Are we together? Okay. So what about the next one? Tan x. That will be sec squared x. Sec squared x. Beautiful. What about this one? We have square root of x. We go back to our primary school. To solve this. Remember that we can rewrite this as what? X raised to power 1 over 2 by law of indices, right? So we'll now differentiate this now, because this is now in the form x raised to power n. So what will it give us? Derivative will now be 1 over 2, beautiful, x raised to power minus 1 over 2, excellent. That is 1 minus 1 over 2. That is minus 1 over 2. Beautiful. I love that. Minus 1 over 2. Okay. But usually, you will not see your answer written in this simple form. they want you to apply some laws of indices that you understand to transform this. Okay, so what can you transform it to? This will become 1 over 2 multiplied by, because of the minus you have here, that will be 1 over, right? Good. 1 over, that will be x raised to the power 1 over 2. Excellent, excellent. Now, again, you still need to apply another law of indices to make this look more beautiful. Okay, so this will now become 1 over 2. Apply that law of indices, you're going to have 1 over square root of x. So if you now multiply these two, you're going to have 1 over 2 roots x. 1 over 2 roots x. So, can we go on to the next? Okay, so this, to find the derivative of this, we have dy dx is equal to minus 4, beautiful, x is power minus 5, excellent. But we can apply law of indices again, and that will be, yes, minus 4 times, good, 1 over x raised power 5. Okay, so we don't need to apply any law of indices again, right? So, but don't forget that this minus 4 is the same thing as minus 4 over 1. So numerator multiplies numerator, we have minus 4. Denominator multiplies denominator, we have x raised power 5, and that's it. So what about the last one? This one is very simple. Cos x, derivative of cos x minus cosec squared x, beautiful. Or we write as well, minus csc squared x. Please take note of that. Anywhere you see csc, it represents cosec. Okay, now we now have more beautiful example here. So we have a function that is equals to 1 plus root x squared. 1 plus root x squared. So we just need to go back to our primary school. You need to expand this first and simplify before you now take the derivative. Okay, so expanding this, we have 1 plus root x multiply 1 plus root x, right? Good. So if we expand this, you see that I've not changed the value from y. It is still y because I've not done any derivative. Okay, so 1 times 1, 1. Then 1 times root x, that will be plus root x, right? Then root x times 1, we have plus root x, right? And then root x times root x, that will be root x squared. Okay, beautiful. But root x squared, the square will take care of this root. Okay, and you have x left. So that we have 1 plus 2 root x plus x. Okay, so that is our y. Again, we cannot apply law of indices. So that just becomes 1 plus 2 x raised to power 1 over 2 plus x. Now we want to take the derivative. So dy dx will now be, look at the first term here. The first term is a constant, right? So what's the derivative? 0, okay? Plus here, we have something that looks like k x raised to power n. Okay? K x raised to power n. So how do we say we do that? That will be k n, okay, x, then n minus 1. Are we together? Then plus, this one is still the same thing as x raised to power n, but n in this case is what? 1. Okay, so we have 1. And then we are supposed to write x raised to power 1 minus 1. Okay, so we go further to simplify. This is 0. 2 times half, that is 1. Then we now have x, 1 multiplied by anything, still that thing, right? Then we now have x power minus 1 over 2. Then here, we have x power 1 minus 1 is 0, so we have x power 0 being 1, then 1 times 1, 1. Okay, we have plus 1. So this we can simplify as 1 plus, applying law of indices here, we can't leave this one like this. So applying law of indices here, what will it give us? 1 over, because of the minus, and that will be x power half, okay, so we have 1 plus 1 over root x. Now, you may leave the answer this way to school. If you see the option that look like this, fine. But you can still make it look beautiful by finding the LCM, and the LCM is just root x, okay? And that will be root x